Okay, today we're going to be talking about estimating irrationals. What we're going to be able to use with the estimating irrationals is we're going to be able to take our perfect squares and utilize those to be able to give us an approximation. The main thing today for you to be able to learn is I want you to be able to understand how to use those perfect squares to get a good baseline of what two numbers it might fall in between, but to also understand that we are approximating. These are not exact values, they're approximations. So if we start off with the square root of 16, like we did today here in class, we were able to say that, well, the square root of 16 equals the square root of what number times itself? Well, 4 would fall into there. So the square root of 16 equals 4. This is an exact answer. It is equal to it. We can do the same thing with the square root of 25. If we have the square root of 25, that equals the square root of what number times itself? Well, the only number that falls into there is 5, so we pull 1 out, and the square root of 25 is exactly 5. Same thing with 36. The square root of 36 equals the square root of what number times itself? 6 would fall in there, and we would get 6. The square root of 36 is exactly 6. But now we run into a problem. When we look at this one, we have the square root of 8. The reason why this is a problem is because 16, if we look up here, 16, 25, and 36 are all part of our perfect squares. Because they're perfect squares, their answers come out to be nice, neat, whole numbers. However, when we're dealing with the square root of 8, the square root of 8 is not a perfect square. And so when we get the square root of 8, we're actually going to get an approximation, and that approximation is going to involve a decimal. This is the type of problem that we're going to solve today. So before we can solve it, we need to truly understand our perfect squares. These are our perfect squares, and they go on forever, but these are the basics. The way we found these is we took 1 to the second power, 2 to the second power, 3 to the second power, 4 to the second power, and so on. So 1 to the second power, or 1 squared, is 1. 2 to the second power, or 2 squared, is 4, and so on. These are our perfect squares. With these being our perfect squares, we can utilize this to find something like the square root of 8. Because we know our perfect squares, we know that the square root of 4 is going to give us 2. The square root of 1 is going to give us 1. The square root of 9 is going to give us 3. So let me continue these on. This will be 5 squared, 6 squared, 7 squared, 8 squared, and so on. So when we find the square root of our perfect squares, they come out to nice, even whole numbers. And it's the whole numbers here before we take them to the exponent. And so if you have the square root of 1, it's 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, and so on. If we're trying to find the square root of 8, well, 8 doesn't line up as a perfect square. And so we need to be able to approximate. What you should be able to see is that the square root of 8 falls somewhere right in here, because 8 lies in between 4 and 9. Because the square root of 4 is 2 and the square root of 9 is 3, then the square root of 8 is going to be somewhere in between 2 and 3. In fact, I would say that it's going to be closer to 3. The reason why it's closer to 3 is because the square root of 8, or 8, is closer to 9. If I wanted to give it a numeric value, I would say the square root of 8 would be approximately, because we're just taking a guess and estimating, 2.8 or 2.9. Okay, here are perfect squares again. We already did the square root of 8, so let's move on to the square root of, square root of 27. I'll move this off. The square root of 27, well, we need to find which perfect square does it fall in between. Well, 27 would fall in between 25 and 36. Right? And 27 would be closer to 25. And the square root of 25 is 5. So we're going to say that 27 is or the square root of 27 is approximately 5. Okay? We can get a little bit more exact because we're going to know it's going to be a little bit more than 5 and maybe say 5.2. We're definitely going to, though, know that it's closer to 5 than it is to 6. The way that we know it's closer to 5 than 6 is that 27 is closer to 25 than it is to 36. Let's try 130. If we try to find 130 on our perfect square number line that goes on forever, it would fall kind of right in here. 130 is fairly close to in between 121 and 144, fairly close to the center, but I think you would agree that it's closer to 121. In fact, it's only 9 spaces away from 121, whereas it's 14 spaces away from 144. And so we're going to say that it's approximately in between these two. The square root, let me move this off to the side. The square root of 121 is 11. And the square root of 144 is 12. So we're going to say it's closer to 11 than it is to 12. Okay? But it's still somewhat in the middle, so I'm going to say approximately maybe 11.4. If the square, instead of square root 130, if it would have been something like square root of 122 or 23 or 24, then I would have gone like 11.1. Whereas if it would have been something like square root of 142, it would have been really close to this 144, then I would say it'd probably be something like 11.8 or 11.9, something closer to 12. That's how we are going to use our square roots to approximate. In class, we will then take these approximations and be able to graph those on number lines. If tonight or tomorrow, if you struggle with using the perfect squares and want to use your calculator, you can also do the same thing. Those are available as well. So I hope that helped get the basics of estimating irrational numbers.